This podcast is for entertainment purposes only and does not provide investment, legal, or tax advice. Hosts and guests may hold positions in the assets, protocols, or companies discussed. Vanishree, welcome to the Signaling Theory podcast.
Amazing. Great to be here, Rex.
So I cannot wait for this conversation about ZK and distributed proving and all of the things that really kind of underlie the next generation of blockchain and distributed compute. But before we jump right into it, can you just give a really brief introduction to who you are, what you're working on, and what brings you to this conversation?
My name is Vanishree. I'm founder of Firma. Firma is a universal proof market. And more about my intro is that my background is in cryptography, PhD in cryptography, focused on ZK, MPC, etc. Architected blockchains, including the MENA protocol, and now we are focused on Firma.
All right, great. So the first thing I kind of have been like kind of cooking on and can't wait to ask someone who's just like, you know, arms deep into the ZK space is frankly, like the big hairy question that's in front of us, which is for years now, have been so bullish on this idea of ZK provides verifiable compute. And we can kind of unpack like the different types of ZK, the zero knowledge properties versus the verifiability properties, and blah, blah, blah. We can unpack all the different aspects of ZK. But at the end of the day, I have always been bullish on this idea that ZK allows us to essentially compress computation, project it into a blockchain, and then verify it so that you effectively can like project arbitrarily complex compute into a blockchain. And I thought like that was going to unlock the next cycle or the next like whole craze of blockchain, because like for the first time ever, we were not going to be able to do just these like incredibly computationally simple things like balance changes or like maybe x times y equals k, like computations. We could do like real modern computations. And like I'm looking around here at the end of 2025, and like I'll just be frank with you, like aside from ZK just getting better and better at doing the base like proving blockchain transactions, like I don't really see any of this like next generation unlocking that I thought we'd saw when these primitives became so locked in and so performant. And so I guess my question for you to like kind of put a bow on this is like verifiable compute seems like such a strong value prop, but like frankly, where are the applications?
Good question. I think it hits at what is the right other piece of puzzle. ZK is one piece of the puzzle. What are those? This other piece is not probably everything in the world, but there are some things. And what are those things? So your question is, what are those things? So it comes down to effort versus value, right? You want to have your effort this much and value this much, only then this thing makes sense. When your effort becomes this much and your value is this much, then that effort does not make sense. So ZK is effortful in proving. It takes time in proving. There have been advancements in proving speed and proving cost. With that advancement, the effort goes lower and lower, and things that are here also become amenable for ZK. Now, what are the use cases where it does make sense is it's a product question, right? Like somebody comes with a product, somebody comes to achieve something on chain, and they come with a preset UX and preset set of constraints for the product to be successful. The proving time adds to user experience. Proving cost adds to user experience. When they come with it, ZK may or may not make sense, right? It does make great amount of sense in roll-up case and in cases where and similar adjacent use cases where you have a bunch of microtransactions, and on-chain work is expensive because every person in the validator pretty much does the same amount of work, and microtransactions, batching them and proving them makes a lot of sense, because even when your effort is high, the effective effort of the network decreases because everybody doesn't need to do that everybody doesn't need to do the verification of those every single microtransactions. There is one person who does some extra effort, the prover, namely, some extra effort. The everybody else only need to do constant tiny amount of effort to verify that proof. So it makes sense there. There are also, I think this is the use case that makes the most sense to me. I do not believe that ZK is the right tool for AI. I do not believe that ZK is the right tool for off-chain data access, for example, which is a very recurrent operation in pretty much all useful apps, right? They need price data. They need um, what is the health of some credit that is given to a person, right? All these things are often data access or accessing beyond the local state of the application. So all these things, ZK is not the right solution. Why? Because it's either, even at this level, it's either too slow, too expensive, or overkill, just overkill. There are other solutions that fit. So you come with a product question, it's a constraint system, and you need to solve that constraint system. The solution of that constraint system is not ZK at that time. The solution, I think, is TE. Why? Because TE gives you enough level of security for those use cases, and it hits the constraint in time and cost perfectly. This is why I think, for example, off-chain data access. Um, Anyone who is running Oracle networks, these Oracle networks, I think they'll go a long way if they adopt. There are so many gaps in current Oracle networks, but they can actually solve a lot by deploying their machines that do off-chain data access, URL access on a TE, and give attestations and have that verified. You can get that verifiability level. TE attestation level verifiability is enough for these things. All these attacks that are happening in TE, they are mostly around privacy of TE. They're not around integrity guarantees of TE. So this is why I do believe that TEs are a good solution. So all in all, my answer, to summarize my answer, is I said this middle model of effort versus value, and I think it keeps changing. And I do think that ZK makes sense for some, and TE might make sense for others. There are other modes of verification. Also, ZK is only one way of verification. Verifiability of computation, on-chain execution of computation is important. ZK is only one. And it's great. It works great for some.
No, I mean, I think that is definitely the right way to like set the stage for the conversation, which is at the end of the day, ZK is just a tool of which multiple tools can provide the same value, which is how can we take the output of computation and verify that that output came from, running computation without like manipulating it or in some way affecting what the outcome is. Like, the code that's supposed to be run and what the answer was, and you can verify without having to actually be the operator that that answer came from that code. And that can happen through ZK, which is essentially like happening entirely through software, or that can happen through TEEs, which is partially through software, but also has a hardware component. And both, this entire world of verifiable compute, I think what one of the worst things that happened to ZK, right, is this name zero knowledge, because zero knowledge almost has nothing to do with verifiable compute. It just kind of comes out of the same research, or I don't know. I mean, maybe you as a researcher might like push back a little bit on that, but the point is that what we're really interested in the blockchain space is less about how do we use ZK and even use TEEs for this privacy and secrecy enforcing aspect, and much more about how do we allow what I like to say is how do we allow resource constrained systems, of which blockchains are the ultimate resource constrained systems, to run like arbitrarily complex compute without actually running it themselves. And I think that that's what we're talking about here with verifiable compute is that. And so, would love to hear if you have any more riffs on that. And I want to bring the conversation eventually back to like what are the actual applications that would use this. But I let's like spend a few cycles on ZK versus TEEs. Because like, look, I'll be honest with you. Like when I look at TEEs, I think like this is almost anathema to blockchains. Like this is like, hey, let's go into a space that is using cryptography to say that we don't need to trust anyone, and then add in this explicitly, like it's in the name, right? Trusted execution environments, like add in explicit trust back into the system, and then like have some ZK to like kind of remove, or sorry, has some cryptography or some encryption to try to remove that trust again.
No, I think that's a great point to unearth this um, I think there is a narrative that has there is a narrative around cryptography being the holy grail and T being awful. I think there is so much about it that we on the face value take cryptography as a godsend and T as untouchable, right? Why? I think so. I think so because because of all the privacy hack because of all the um, ways people have figured out to break privacy of TE, but it still remains the case that TE is gives you that level of security for integrity. So TE also, just like ZK, like you explained really well, ZK gives you two things, privacy and integrity. TE also gives you two things, privacy and integrity. Privacy of TE is questionable. Integrity of TE is not as strong as ZK. However, however, TE comes at low cost and low speed. There are applications where low cost and low speed is important, and the value that you're protecting. So oh, I think this I wanted to say. Here's another model, right, Rex. The model is the amount of money you need to spend to break a fort has to be more than the amount of money it's securing. Only then will someone break it. So they are very comparable. ZK and TE are very comparable because they offer similar things, but TE offers one more thing that you can associate a notion of identity to the source. You can say that this in a network of AI agents around the world, one of the things that is very important in the future is having a notion of identity to an AI agent. Uh, why? Because it'll help you to have SLAs with that AI agent. You can say you put money, you give me some economic security if you do something, I'll slash you. If you and they can also, on a positive side, they can build reputation. So it's all tied to identity, and T's give you that identity. ZK doesn't at the base level. You can add a notion of identity on top, but still, TE gives you that. I think my point is the point I'm trying to get at is TE at once. I think we should not completely keep them aside because there are use cases where they can be useful, where they actually where they actually hit all the constraints.
And again, maybe I don't shouldn't be like kind of belaboring the point, but just from first principles, right? Like when I think of what is the value of a blockchain, and we'll just use Ethereum here, right? Like it is the idea that I, as a relatively non-technical person, can participate directly in the network, and by participating directly in the network, I am both contributing to and guaranteeing the credible neutrality of the network. And that's like the fundamental purpose of every blockchain, whether or not they're even like trying to achieve it, right? But if you're not doing that, you're essentially creating financial applications on AWS and then wrapping it in some sort of like blockchain wrapper for like VC or regulatory reasons.
That's a great point. Oh, yes, that's a great point. So you're right that we shouldn't have one TE that is doing everything. We should still have permissionless. We should still have permissionless access to the service, blockchain service, and we should have uh, a notion of a convincing model that'll tell us, despite these limitations of TEs, you still have a convincing model that this is trustless. Let's get back to this, but there is one point about cryptography, which is that there is still an assumption that it is there. You're relying on an assumption. You're relying on an assumption that nobody has figured out how to factor product of prime numbers. There is an assumption that people don't have better than very difficult algorithms, algorithmic solutions to finding a discrete log of a number in a large field. There are these assumptions. We don't know whether maybe somebody has it. We just don't know, right? Same is for TE. Nobody has figured out how to, beyond certain level, how to break integrity of TEs. That's an assumption. It's all about the history. There isn't something so special about math here. It is just that in the history, people have tried it and they haven't found a solution. It's the same thing. At a basic core level, it's the same thing. So with the notion of TE, you're not letting go of any access to something. You're not letting go of permissionless access to something. You're not letting go of the level of security you can give to a system for certain applications. You're not letting go of it as long as you architect the system correctly. What you're 100% right. You should definitely not say, okay, here is a TE. It'll give you enough security. We have deployed it on AWS, and that's it. So I agree with you. That is against the direction we all are going. Instead, think about something like this. Thought experiment. Think of something like this, right? A network of validators where they also have TEs for certain use cases, and those TEs will run certain operations. Now, what happens there is something that runs for too long does not need to run on chain. And this is exactly why people are using ZK. Something that is too expensive, not need to run on chain, you create a ZK proof. What I'm saying is, do the same thing for TE. Something that runs too long, put it in a TE, give an attestation. People will reach consensus on the attestation being correct. So there is that level of security still. Not one TE, network of TEs, network of validators, doing consensus on execution, but you reduce the overall effort of a network by putting some operations inside a TE.
I hear you. I think I have this very strong belief that um, at the end of the day, like it is really, really hard to get people to run validators, right? Whatever kind of validators they are, right? And I'm an Ethereum home staker. Like even though it's not that big a deal, like it just sucks, you know. Like there's really no upside to it, and like you kind of just have to be like a fanatic that really believes in crypto and like the credibly neutral idea. And you know, Ethereum struggles so much with just like maintaining this validator set, and really nobody else is able to maintain any sort of credibly neutral, let alone like home staker validator set. I really have this theory that, you know, when we look forward 10 or 20 or 50 years, like we're not going to have all of these networks of people running nodes. We're going to have one network of people running nodes. And like why I kind of fell in love with the eigenlayer idea when it first came out, and why I'm a little bit disappointed at the like turns it's taken, is because what I understood eigenlayer to be saying is that we understand that long term there's going to be one network of computers that run distributed software, and we are going to allow them to like we're going to basically use the Ethereum validator set and allow them to opt into more and more services like based on the amount of like compute they bring to the table. And so I think kind of like in that future, I can kind of see this world where some of the Ethereum validators like may have enough money to like buy like specialized hardware like TEEs that like can run these like highly intense like computationally intense things off chain and then put it back on chain using attestations. And maybe that's how these things works and that's fine, but to me like the best case scenario is like TEEs are really just a stopgap solution while the performance of ZK and the cost of ZK like isn't quite there. And like long term, we should like the ideal case is that ZK is, you know, just like very minimal overhead can be run on basically any computer. When, you know, we see like the extended Moore's laws, like improvements we've been getting on ZK, like you know, in that world, do you think like do TEEs really have a role in a world where ZK doesn't really require that much overhead, or like do you still see that there are fundamentally different things that ZK will be good for and TEEs will be good for, and like that is not going to change over the long term?
I think ZK will start eating more and more and then it'll stop.
Mm-hmm.
I think with ZK advancing, it is eating more and more of computation that it can handle, but then it'll stop. The reason why it'll stop is I think that um, there is this fundamental limitation of what you can do with ZK optimization. These are complexity theoretic limits. I don't think the exact limits we know, and we have reached that optimal limits of ZK. There is a limit, and the reason why there is a limit is ZK works in this the way we get benefit of ZK is by saying that okay, two people, what Rex does some computation, I need to verify it. Uh, how do I really reduce my work? Is by making Rex do a little bit more work to make his explanation super easy for me. You have to do that little bit more work. In complexity theoretically, you have to do that extra work, and that extra work might make sense for certain things and might just not make sense for other things. Off-chain data access is such a good example. It is such a simple operation that ZK proving this entire thing can be too much, even at the levels of getting super close to the computation itself. That's what I think. There are limitations on how much you can go.
I hear that. I think like the counter to that would be like, you know, look back at what they were saying the limitations of compute would be in the 90s. And like, I think like the one thing that we're good at is like just kind of destroying the like theoretical limitations and just like getting better and better to the point where sure maybe those limitations exist but like because we can process them so fast like they are not important to blocking progress forward. And I guess like kind of where I'm trying to the thesis that I want you to ultimately respond to is that I understand this concept of like, okay, maybe TEEs are the appropriate way to implement a lot of this functionality that we care about in the short term, and then in the long term, we can go back and replace that with ZK cryptography. Um, and you know, one, I would like to hear if like that's for many of these things the path that you see us going down, and if if so, like my question is, why are we bothering to like do the T's in the short term? Like frankly, I just like look around in this crypto space and like we talk about things like crypto economic security and then we don't actually value it, right? Like we talk about how important it is to like have X amount of capital staked in eigenlayer and then like okay there's never been a slashing event and so like these concepts that that like seem like they're so important to add these levels of security, they turn out to not actually be important today. And so I guess what I'm nervous about is like, are we going down this like trusted centralized route and building in like vendor lock-in or incumbent lock-in into TEs as a stopgap solution, when really like that's going to cause us problems down the road for value that is like really unclear today.
There are situations that have happened there in just the recent past that um, makes me think that having a TE based security is worth it for these products that don't even have any level of security beyond some degree of repetition. Think of Oracle networks. What do they do? Typical Oracle networks. What do they do? You ask for price feed. They have chosen set of maybe 10 machines. They do a median and they give it to you. Now, what is the guarantee that they will actually give us the actual value and not steal value? What is um, what is the kind of SLA they'll give us in terms of if something goes bad? What kind of resolution they are going to provide? Um, how do I know what how do I even know that this is exactly the time it was accessed? How do I know that this is even accessed by a machine that is um, what if it is saying that it is making up a little bit of volatility by itself, has some model, has some volatility model and creates volatility within that area and for every 1 minute, and then gives me approximate values that way without actually doing the work? We don't know. This so Moonwell recently lost $1 million. The reason um, Stream Finance lost a ton of value recently, 90 something $1 million of user funds, right? These are not like one-off things. A million is significant, upwards of 90 million is significant. And these are not one-off situations. These happen over and over again. This off-chain reliance, where there is no clarity on what kind of security they're giving in off-chain networks, that is where what I'm saying. So I'm not saying that these things are already run by validators. These things are not run by validators. These things are run by off-chain networks, and they don't provide any level of decent security. This is why these hacks keep happening. It's not, things break not because okay, there is this consensus protocol somebody built, and this is they had a chain quality value delta wrongly set, and that is why chain. No, we barely hear about anything like that. All we hear is a bot mishandled something, an oracle went down. It's always the off-chain thing because chains are built to be secure. They're unfortunately made to rely on off-chain networks. Off-chain networks don't give that level of security. They can get a lot farther by adopting TE and by having validators do that. Why is it good for validators? You made a great point. Okay, it's very hard to get people to run validators because there is OpEx and CapEx, and the revenue that they're getting is not matching. You can increase revenue opportunities by doing more operations on chain, and you can um, you can also have that level of on-chain security for those operations, on the other hand. And for these, we of course are not going to ask them to have a machine sitting aside all the time for some long-running task that'll come every now and then. This comes. So there are two questions. One is this a direction good enough for this space? And the second is, can we architect a solution where it'll make sense for parties involved? So these are two solutions, two things, right? With respect to restaking protocols, they have demand and supply. If they increased the supply so much that they don't have enough demand, of course it doesn't make sense for them. So it's about maintaining this, like high number of um, high amount of money inside this restaking does not give you does not give these people enough value if there isn't demand. So there it's a product's goal then to keep this aligned at every single point in time to increase the utilization rate of every machine involved so that they are actually making money at any given point in time, really making money with respect to OPEX and CAPEX. And I do think there is a separation of sorts between these two. This is why I think that there is a direction where we can go, and product has to figure this out.
So, okay, before we like just move on to the restaking the supply and demand piece, which I think is important. Like, I think it's impossible not to acknowledge just that Eigenlayer got, and then all the follow-ons got way overhyped. Everyone wanted to put their capital in, and then there wasn't enough demand to pay real yield against that capital, and that has caused like kind of the like over the bubble like nature around restaking. So we'll get there in a second, but just on this example that you used of an Oracle network, right? Like when I look at an Oracle network, like it is totally true that today how it works is off chain. A single computer will bundle up a bunch of inputs, maybe from third parties, maybe from their own work or whatever, right? They'll bundle up a bunch of inputs. Then they'll find some way to consolidate all the inputs into one thing, whether it's the median or the average or whatever, right? And then they take that value and then they post it on chain. Then I think what you're saying is like, okay, we can introduce a TEE into this architecture by saying, okay, Oracle endpoint, we want you to have a TEE so that like we know that you're actually taking in all the inputs from all the places that you say that you're taking in. You're running it against the code that you said that you're going to be running it against. And because you use the correct chip that like gives us an attestation and you've given us a copy of the source code, we are able to verify that, okay, based on the inputs you got, you actually ran this code and you got this output and now it's on chain.
Exactly.
But like, I guess my question to you is, does that like, what's the value of that? Right? Because like at the end of the day, like all of these hacks or all of these like problems, like really aren't they upstream problems? Like how often is there an issue that like someone actually hacks into the code of the Oracle network and then is able to manipulate the outputs and put in bad data that leads to losses? Right? Like that's not really what's happening.
I think it is about knowing integrity even before you use the info. Let's say you get some info and you use that info, right? You get info from these articles. Let's say they look at. Let's not consider a price feed because it can be very time sensitive, and there are applications that where you may not even have time to verify this. Instead, let's think of a use case where you're a prediction market, okay, where you want to see who won in this election, and there is an oracle that goes and fetches this info. Now, Venezuela election happened, and there was an issue with how Polymarket resolved the market because of this off-chain reliance on an external Oracle network. Now, um, why this can be significant is this issue of relying on external networks creates this bigger issue of misaligned incentives between your core protocol and an external protocol. What is the goal of UMA protocol? Make money. What is the goal of Polymarket in this situation? Resolve the market correctly. And they're clashing. They are working together. There is a possibility of them clashing, is what I'm saying. There's a possibility of them clashing where conflicting, where exactly that situation was created um, in Polymarket and UMA protocols collaboration at that time. Now, um, what I'm trying to say is that in the event where this off-chain data access is not time sensitive, you can take that input from a TE instead of relying on an oracle that instead of relying on even if the oracle network change the oracle network change UMA protocol's architecture to having these machines running on a TE and actually doing some access and then giving an attestation and then Polymarket using it. That already changes the game. You reduce occurrence of such fiascos already there.
Why? Because like in this example, what you're kind of gesturing to is like the inputs of UMA protocol might want to give a false answer because they are getting paid to give a false answer, right? And so in that case, like it doesn't really matter if it goes through a TE or not. It's still going to run.
But Polymarket can verify. But Polymarket can verify before taking this input. Let them, they gave input earlier, they are giving input now with T. Without T, they didn't have a way to verify. Now they have a way to verify before accepting it. No, the attestation. Oh, great question. Gets into the actual value proposition of this direction, right? The attestation says that the code that you ran actually accessed this URL, which is an official place that announces the person who won. So that's where they're accessing. These oracles need to access that URL, figure that out, and that's where they accessed.
I guess in that case, though, if there is an official URL where you can access this information, why does Polymarket need UMA at all? Why don't they
Ah,
just access it?
you hit the biggest gap of current blockchains all at once. They're all synchronous. They cannot do off-chain data access themselves. That is exactly why we needed a band-aid in the name of oracles and became a huge industry. Why? Because it's such a repeated operation. This is why we have oracles. They just can't.
So I guess what you're saying is that it's not that so you can say the smart contract that Polymarket deployed is able to verify that this UMA, like whatever result UMA is putting down, came from a specific location, and that's not verifiable.
Because of problem in UMA, there is zero problem in Polymarket. Polymarket has its own architecture, but UMA protocol is not whatever they're doing, they don't have any guarantees on them doing the work correctly.
Yeah, no. Yeah, that makes sense. And I think the other ways that people have solved it, like before that, like, Chainlink tries to solve that, like by staking link tokens, and then it's a slashable offense if they can attribute like malicious intent. And so, I think that is probably the good segue to talking about like why restaking is so important in this, because like verifiability by itself is doesn't mean much, right? Like you need to be able to verify, and if you verify that something was incorrect, like there needs to be consequences, or else like what are we even doing here? And so I think one consequence is, well, you can just like reject the answer, and then but I think what we've been saying with restaking is, hey, let's put some economic value behind your promises, and then if the promises are verifiably incorrect, like we have something to punish you with. So one, do you think that's a good like kind of explanation of how all these things work together? But two, I'd love to just like kind of get your take on the evolution of the restaking space, and as it exists in 2025. Do you think that we're delivering against the promises that we kind of had while these ideas were so new, or what do you think? How do you what's the lay of the land of like restaking and then verifiable compute in 2025?
I think there is such a big gap between restaking and verifiable compute. I would consider that to be two separate things. I think um, there might be a way to go from restaking to verifiable compute, but here is the more fundamental relationship between verifiable compute and something else. Verifiable compute and economic security. You can get economic security either through restaking or just economic security. Um, there is economic security. So economic security is it comes down to how do you design your mechanism of a market, and the design of mechanism can be strong in some cases where you put um, where people who deliver some work put some stake, um, and I think I think there I think there might, yeah, in my view, there is a strong correlation between verifiable compute and economic security as one of the tools to make this work. It's just one of the tools to make this work. It's a mechanism of an entire market. It's one of the components. I think restaking is completely aside. I think of this as a different narrative.
And so I take your point that economic security is really the tie to verifiable compute, and while restaking is one type of crypto economic security, there's other types, right? Like insurance. I don't know. I can off the top of my head, the insurance is what I thought of. And so I guess the like when you think about verifiable compute, how much do you think like there the you need both sides of this coin, both the verifiable commute and the economic security, to build systems that are like providing real value above and beyond we had these technologies before? Or do you see like verifiable compute is like most of the prize here, and then economic security is really only important for super high value, maybe like financial types of applications? Or I guess like how much do you understand these to be like two things that are locked into one story versus like two things that just have a relationship?
I think of this as like um, an assurance. Think of assurance as a box. Now you need to fill that. If you want to take somebody's service, you need to see the box filled, and there are different ways of filling the box. One is completely put ZK, fill the whole thing with ZK. You don't need any economic security. The fact that ZK has soundness property that you can, it doesn't matter how you did it, how you did the work, as long as I can verify the proof, I really don't care how the work was done. So there is that ZK is that assurance. You don't need economic security there at all. You bring, or the other extreme is I have no idea to verify the compute that you're doing. I have no idea. Please put money behind it. That's the other extreme. And there are middle grounds you can have. Like we talked about TEE. Maybe there is not enough confidence in just TEE. Put a little bit of money to you can associate some probability with which it can get broken, and you associate money filling the part of that box with money, crypto economic security. Now, the other ways are doing the same work over and over again and giving it to multiple people and taking randomly and then seeing. I think Hyperbolic has this protocol called proof of sampling, and their core idea there is in to verify whether an AI compute was correct or not. It is hard to ZK prove it. It is hard to have a whole full-blown consensus on that, because if you have everybody do the same work, it is hard. They have this random choice. Different people, they do the work, and then you match the work and you see whether they are the same or not. You can do that. I think all of these. I think uh, my mental model, the way I like to say it is, look at this as a quiver of all arrows you can use depending on what the situation is, maybe you need two of them, you need one of them. You can they're all arrows. They're economic security, ZK, TE, repetition, consensus, KYC, the person doing something who is putting not money but reputation behind. These are all different ways of achieving assurance and compute being correct, and we can choose, pick and choose depending on whatever is required, right? Mhm.
Yeah, I mean, I think everything in computer science kind of like falls into this Lego metaphor where like we all build the blocks, and that's what abstraction is, the ability to like stack blocks on each other. So I guess like we'll use this as a little bit of a pivot to talk about like what you're building with Fermat, and like the positions you take in how this space is going to evolve. Like, feel free to kind of correct my understanding, but I think kind of both the vibe I'm getting from my understanding of what you're building plus this conversation is that you see the verifiability of compute and like especially with TEEs to be one of these Lego blocks that will become like more and more important as we build um, more modern applications. And I'd love to hear kind of what that means to you, whether that's like more applications that are able to access digital economies natively, or maybe it's as we build more applications that leverage AI or any of these things. And what you're really focused on is building that verifiable compute layer so that people can bring their own opinions about things like economic security or consensus or all these other puzzle pieces to build the applications they want. I guess I just asked you in a very leading way, but like I would love for you to kind of talk through what you're building with Fermat and like how that is positioned to like be a big player in this next generation of compute.
Mhm. We started off with proof market, where the idea was that we will build this open market of provers on one side of the double-sided marketplace, and people who want that proofs to be done. And we built this mechanism which would match the seekers. We call them the seekers who seek for proof, seekers and provers, in a way that is optimal for these machines to be on our network. And um, this is our main focus. This has been our main focus. We are expanding, and that the way we are expanding is not yet public. And I kind of in a lot of our conversations, I teased that out here and there, mainly because of our belief in how this area should progress, and this area should progress for having compute that gives integrity to how do you achieve integrity of computation that is run for a person, whether it's on chain, whether it's pushed off chain, whether it is off chain and then on chain, attestation in this whole mix. Where should we go? We talked about it, and we are expanding from this focus of proof market to beyond. Um, and about Firma, more about Firma is that we have ZK Sync, Scroll, and these amazing projects in ZK as our core customers, um, and one of the coolest parts about Firma is that, like you were saying, ZK is just progressing at a huge pace. Matter Labs came up with this proof system that is ZKVM that is unbelievable, called Airbender. We started using using Airbender to submit proofs to ETH proofs, and the proving time is incredible. Real-time proving already hit. Um, Now, to keep pace with this advancement, and for for a user to not really marry the current status of a proof system, you need to be able to adapt, upgrade to newer proof systems, and that's exactly what Firma offers. Firma is this one-stop infrastructure for ZK proving, where you can keep up with the advancements of ZK space and not be tied to one specific ZK VM vendor without having to change. So if you've switched from one ZK VM vendor to another ZK VM vendor and use their prover networks, what happens is you'll have to switch to your entire experience, your the way things get priced, the way things get allocated. Everything changes and not to mention the integration cost. For us, universal proof market, amazing mechanism design that checks off all the desirable properties of a mechanism design. And on top of it, you are not tied to a proof system. You can choose any proof system you want. With proof systems changing, you can integrate a new proof system very quickly, very quickly. I took the liberty of showing a quote from MataLab's team saying, they said that, damn, you guys integrated so quickly and we are so impressed. They built Airbender and we integrated it and it was so quick. We have built the tooling that makes integration with any proof system so quick for any customer. Even they can do it over over a couple of hours for any complex proof system. That's how we did it. So that is our focus. All in all, proof system and then expansion.
Yeah, no, that makes a lot of sense. And I guess I would love to hear you talk through. So, like, one way that you could architect a system, like, let's say I have fine, like, I want to create like a brand new Oracle network and I want it to be ZK proven. And let's say that I like have found like this beautiful implementation of like what's the ASIC, the Jolt, right? And like I love it, and I believe everything's open source, but if not, that's fine. Like, but I have the access to the code, and like I can build my Oracle network. And then one option would be I could compile the prover, put it on AWS, and just run my own prover. Um, and like I'd be my own prover. And then if I want to change from Jolt to I don't know, Risk Zero's Boundless about Risk Zero's product, I can kind of do the same thing where like, okay, like I'm just going to run my own prover, and I kind of like control the whole stack. And so like I don't need to really worry about the switching costs of and like all the pricing changes and like the model behind all of this of like switching between VMs, because I'm just going to control the whole stack. Um, what would, if you're talking to a builder who is thinking in that mind frame, how would you like talk them through why it makes much more sense to go with a prover network or with Fermat specifically?
Yeah, I'll play out how it happened with ZK Sync. They were pretty much one of the first, if not the first, projects to embrace proof market as a category and be a paying customer. And they were using GCP before before working with us. The reason why they switched is um, you need to pay up in three things if you're working with GCP or AWS. One is the cost, because they have very simple reason. They have they love to have high margins of gross profit margins at AWS and GCP. We already cut down the cost already, because on the supply side, the machines we have are machines that are owned by people, and these machines are lying idle and they want to make some money off of it. And to help them make money off of it, we hit a sweet spot that'll work for them, that'll work for our other side of the marketplace, the seekers. So cost. The second one is the whole effort of scaling. You need to figure that out with AWS, and you probably need a DevOps team. You need you need to keep the cost down, and you need to scale properly. You don't have consistent demand all the time. So there is that. The third one is, how can you build out? So it's not just put it in AWS and there is only one machine, right? A prover. If you look at the previous version, Airbender is coming, but the current version of ZK Sync's prover, that has a really complex workflow. It has multiple levels, and each level has multiple circuits. I think it's up to like 40,000 circuits or something in total, right? 20,000 to 40,000 circuits, depending on what is the transaction, what are the transactions in your block. To orchestrate this whole thing is another work, and you change the proof system, has a different workflow. You orchestrate this whole thing. You need to build that out. These are all these. So the third one is upgradability of proof systems. These three things are painful, and that's why it's good to use a universal proof market. That's why universal proof market is necessary.
So those are like all like very like good reasons to that you would make for say like, hey, don't manage your proving yourself. Like you should go with a third party. But like what I'm a little bit missing in there is like why go with a proof network versus a third party who is specialized in this, but like is running a centralized prover just on your behalf, right? And in general, like for blockchain, we think like, what's the purpose of having a blockchain network? It's there is something for sure about like uptime and reliability, but like really why we do it in blockchain is to create this trustlessness where you don't need to trust any people because like you can verify yourself. But like the amazing thing about ZK or even TEEs is like we don't need to worry about that, right? Like it's in the nature of the math that you can verify it whether or not a decentralized network did it or one unit did it. And so I'd love for you to pick apart like why as a builder does it make sense to really build on top of a decentralized proving network as opposed to a centralized one, a centralized prover.
Yeah, we could be centralized too. You can call us centralized too. I think you get to this need. You're attacking this miss um this wrong narrative around prover network on it being a decentralized network of provers. It does not add value. Decentralization actually, yeah, decentralization actually is costly. Somebody needs to pay up for decentralization. Usually, is the person who is requesting proofs. It's suboptimal. That's not the direction where we are going. What we are saying is we have this network, we need machines to prove. If we go with one person, it probably is not reliable. If they go down, they likely will go down entirely. We need, let's say, 50 machines. One person will bring five, another person will bring two, another person will bring. This is how we will orchestrate. We get that level of reliability, and the goal of every market is you have demand and supply. Your supply has to hover right about demand. And you have to do that at any given point in time, right? That's what you want to do. That's exactly what we're doing. What we are not we are not interested in putting how we every single part of this transaction between us, the matchmaker, and the prover, we are not going to put it on chain. It's wasteful. Because ZK Sync and Scroll and all these other parties are happy as long as they receive the proof on time. That's all. And they have reliability on time. So putting this on chain is not going to buy us anything. Unnecessary decentralization of proofs. You can actually build mechanisms, right? Like there are these mechanism design researchers, and they have this vocabulary of different tricks to build mechanisms. There is a class of mechanisms that helps you achieve decentralization. The result in those mechanisms, the pricing is always not optimal. You have to pay up, and that is not the class that we picked from. Our mechanism, we focused on making it optimal for the seeker on the cost and time, and we made optimal for the prover in their utilization rate, and maintaining the supply to hover right above the demand. these are the constraints when we built our when we designed our mechanism. Um, it's I think decentralized Tor network is it's kind of I think a very you're 100% right. I completely agree with you. It's unnecessary and it's just goes against your ability to build a good product.
Yeah, I mean, I because what's funny is when you said like AWS, like they, any of these like mega, or is this what we're calling hyperscalers, or I don't know, but or any of these like mega compute, like cloud computing companies, of course, like they are in the business to make money and they have huge margins, and it's like funny is that it's like, yeah, but when you look at decentralized compute, like our margins aren't that big because but like our margins aren't that big, but we still have you end up having to pay for decentralization either directly or indirectly anyway. And so like I was definitely curious how you can get lower like better pricing in a decentralized method. And it sounds like what you're saying is like for what you're building, decentralization is not like critical. And so maybe what it sounds like you're saying is that what Firma does is like goes and finds operators, and like those could be like highly centralized. They could for their own business reasons be like super decentralized. These are the things that are not really important to you. What's important is just like, do they have the technical ability to run your like kit, which would allow anyone to like submit proofs and then generate the proofs and then get back the or sorry yeah get back their result, and you're sitting in the middle and being the coordinating layer between these entities.
Exactly. Exactly.
And then can you talk through just a little bit, who are these entities? Like are these like who is sitting around with enough like technical expertise and compute that's interested in doing this that haven't like basically purchased that compute for something that they are doing?
Yeah. Um, they are, many of them have had experience mining. Seems like not a thing that they can do anymore. So they have the machines. They I think they try to be part of AI networks and um, our Our goal is a lean operation, and even in our testnet, we have kept it lean, and even in our mainnet, we'll keep it lean. And there, the supply will only hover over demand, and that way, you increase the utilization rate. And this kind of hits right for people in in how we are approaching this. And these are the folks, and this is our offering, and these are the folks. These folks respond well to this offering.
I have to ask you this if you're in contact with these kind of people, because I've seen these stories too of like, especially Bitcoin miners who are realizing that that might not be profitable, but are shifting to try to be like AI data centers. Like, I kind of thought the whole thing about Bitcoin was that everyone was so heavily invested in these ASICs that like weren't really useful to anything else. And so like on the one hand, like I understand that they might have a lot of extra, maybe like power and like energy access, but do they, in order to service whether it's AI or things like proof generation or any of these things, are they having to go buy hardware, or is there some way to repurpose actual mining hardware for the types of things that you need?
I think they probably are not using the same hardware. We have this variety of hardware on our testnet to see how different kinds of um, jobs can be orchestrated at the same time. It's a good question. I don't know. I don't know if they had to buy this newly, and I don't know. I should ask. I'll ask, and I'll let you know.
Okay.
Why do they have those many machines? I know there are whales and there are big um, there are people who have a lot of these machines in China. Um, a lot. They are the ones who are bringing. big amount of power to our network, I should ask why they have that much.
Yeah, well, when you find out, I'd love to have you back on the pod and let's talk it through. But before I let you go, just like on the way out, can you tell me like again, we started this conversation on the applications and like the products, and I don't want to like kind of take us right back there, but I would love to walk out on a conversation of like what are you bullish about right now, and what are you bullish about proving and verifiable compute really unlocking in the next phase of like this story, and that can be anything from like I do believe that verifiable compute has a huge role to play in AI because like what we're learning from AI is we have like no ability to track where anything's coming from. Of course, it has like direct applications in blockchain, and there's just so many more things where these kinds of concepts are becoming more and more relevant every day. So, as you are building these networks and seeing real usage and trying to balance that supply and demand, what are you starting to like really get excited about that you think is going to kind of unlock the next chapter of this story?
Right. So there is a so crypto has seen this category of super high PMF, perp dexes, market prediction markets, etc. That's that I think is one category. I think there is a huge amount of category, a huge big category that we haven't explored at all, and that is imagine your apps. So before I say that, let's look at Web 2. In Web 2, AI has taken over every single app. Every single app AI has taken over. Why has it not taken over Web 3 apps? Here is why. They can't. Technical because um, blockchains don't allow that to happen. We are solving more fundamental problems in trying to solve more fundamental problems in Web3, saying, can we do training in a decentralized manner? Can we do inference in a decentralized manner? These are so fundamental. I believe these are great to attack, and these are so uh, hard, and it it'll be awesome to see that happen. But here is a model. I think it's attributed to Warren Buffett long ago. He was saying something to this effect, but here is an implication of that. Um, refrigerator, someone who invented refrigeration, they had some direct impact. They made some money, right? They made some money. Coca-Cola is the one who used refrigeration and created an empire. What we are trying to do is build, reinvent refrigeration in a better way by having decentralized inference and decentralized training, etc., which is great because it's a necessity. It is great. It solves some of the problems of doing things in a centralized manner, and those problems will get bigger and bigger as the world progresses in the AI direction. So these are great to solve, but there is a flip side to it, which is largely undiscovered and largely not looked at, and that is building applications that are building these empire applications, the Coca-Colas that can use AI for refrigeration, right? That I'm super excited about. Can we have apps that are Perptex transfer of money? Great, blockchains are built for it. You can build that. Great PMF, of course. How can we go beyond that? That I'm super, super, super excited. Global AI is on its track to bring multi-trillion, I think maybe 15 trillion, I remember seeing somewhere, but by this credible analyst, um, 15 trillion to some market GDP, the global GDP. What is crypto's share of it? It's a rounding error. It's just a rounding error. And there is a reason because we are not built to capture that. That's what I'm super excited about. And to go there, You need that. So the good thing about centralized AI is that there is reputation behind it. The bad thing about decentralized AI is without reputation, it doesn't work. You need to have a notion of reputation. You need to have a notion of who you're talking to there. That that's verifiability that connects to the larger notion of verifiability of compute that we have been talking about. That comes. So I told you about the bigger picture that is exciting me about AI. And the lower level requirement is building that infrastructure out, and that I'm super excited about.
Yeah. No, I think your story about yeah, refrigeration, excellent technology, but what's interesting is not just technology, it's what are things that are were not possible before technology existed.
Yes,
And that's really, you know, all of us like nerds here, we like the technology, like we're interested in how things actually work, but like the story of how the world changes is not what is the technology, it's what does that technology unlock. And
great.
I have to say, like with ZK, I kind of was expecting by 2025, 2026 to know what those experiences were, but we still are early and like things are still changing very rapidly. So, you know, the time will tell like what those things are.
Okay. Maybe the ZK, the privacy part will take over though. Maybe.
Yeah, and of course there's so much application there that like how many
Oh
times
yeah.
has all of our everything from social security to like you know like WhatsApp accounts getting hacked like
Yes.
everything is a nightmare like if
Yes.
nothing else if we could just use it to fix the concept of a password like my
Yes.
god
Yes.
so
Different life. Yeah.
yes, yeah. And maybe that'll tie into the story of verifiable computer. Maybe those are kind of like brothers that are telling different stories. So
We'll see.
yes. All right, Vanishree, thank you so much. Before I let you go, can you just share with the audience if they have been inspired by this conversation or want to learn more? What's the best way to find you, and what's the best way to learn more about Fermat?
I am Vanishree underscore RAO Rao on Twitter. Anybody wants to. So actually, we are building this SDK. If you don't mind me plug this, adding this plug, we are building this SDK. We have this core group of developers who are trying out this SDK. We want to get more people to try this. I will give a link to that to you if you can please add that next to this episode, please.